Hello friends, this is Darwin Patel. Welcome to the lecture series of Mathematics 2. In this lecture, we will discuss about the Fourier cosine and sine integral. In the previous lecture, we discussed how to find the Fourier integral for non-periodic function. First of all, we recall the Fourier integral for non-periodic function. Fourier integral for non-periodic function fx defined on minus infinity to infinity given by fx equal to integration 0 to infinity a omega cos omega plus b omega sin omega d omega, where a omega is given by 1 upon pi integration minus infinity to infinity fx cos omega x dx, and b omega is given by 1 upon pi integration minus infinity to infinity fx sin omega d omega. Now, if our function is defined on minus infinity to infinity, that means it is defined on whole real line, then we can find Fourier integral by this formula. But function is not defined on whole interval, but it is only defined for 0 to infinity, then we can find our Fourier cosine integral or sine integral according to our functions defined on other side as even or odd. Let us see how to find the Fourier cosine integral. Here, if function fx is defined on only 0 to infinity, then we can express is on minus infinity to 0 such that our function should be even function. Then our Fourier cosine integration is like fx equal to 0 to infinity a omega cos omega d omega, where a omega is 2 by pi integration 0 to infinity fx cos omega x dx. Here we define our function on negative side minus infinity to 0 such that our whole function on minus infinity to infinity will be even function. Then b omega is directly 0. So we can find the Fourier cosine integral given by this formula. Now Fourier sine integral of non-periodic function is given like this. If our function is defined on positive region, that means it is defined for x greater than 0, then we define our function on negative side, that means for x less than 0, such that whole function will be odd function. Then our Fourier sine integral is given like this type. Fourier sine integral of non-periodic function defined on 0 to infinity as fx equal to 0 to infinity b omega sin omega d omega, where b omega is 2 by pi 0 to infinity fx sin omega dx. Here our function is only given on the region 0 to infinity, but we expand this function from minus infinity to infinity such that our original function will be odd function. Then a omega will be 0. Therefore our Fourier sine integral is given by this formula fx equal to 0 to infinity b omega sin omega d omega, where b omega is 2 by pi 0 to infinity fx sin omega x dx. Now we will see some example regarding this topic. Here fx equal to e raised to minus x sin x, where x is positive. We have to find the Fourier cosine integral of our function fx equal to e raised to minus x sin x. Here our Fourier cosine integral of fx equal to e raised to minus x sin x is equal to fx equal to 0 to infinity a omega cos omega d omega, where a omega is 2 by pi 0 to infinity fx cos omega x dx. Now a omega equal to 2 by pi 0 to infinity fx cos omega x, that implies a omega equal to 2 by pi 0 to infinity e raised to minus x sin x cos omega x. Here we are taking the 2 inside the integration, then we get 1 upon pi 0 to infinity 2 times e raised to minus x sin x cos omega x. We are applying the formula 2cs. Then finally we get a omega equal to 1 upon pi integration 0 to infinity e raised to minus x sin omega plus 1x minus sine omega minus 1x dx. After separating the integration, we get the 1 upon pi integration 0 to infinity e raised to minus infinity sine omega plus 1x dx minus 1 upon pi integration 0 to infinity e raised to minus x sine omega minus 1x dx. Now after integrating by this formula, we get 1 upon pi into e raised to minus x upon omega plus 1 whole square plus 1 into minus sine omega plus 1x minus cos omega plus 1x from 0 to infinity limit and minus e raised to minus x upon omega minus 1 whole square plus 1 into minus sine omega minus 1x minus cos omega minus 1x for 0 to infinity limit. Now we will put this limit in this integration. Then we get a omega equal to 1 upon pi 0 in minus e raised to 0 upon omega plus 1 whole square plus 1 into minus sine 0 minus omega plus 1 cos 0 and minus 1 upon pi into 0 minus e raised to 0 upon omega minus 1 whole square plus 1 into sine 0 minus omega minus 1 cos 0. As we know that e raised to minus infinity is 0, then our upper limit is directly 0, which is given in the red color, and as we know that cos 0 is 1 and sin 0 is 0, after putting this value in our this term, we get a omega equal to 1 upon pi omega plus 1 upon omega square plus 2 omega plus 2 minus omega minus 1 upon omega square minus 2 omega plus 2. After simplifying properly, we get a omega equal to 1 upon pi 4 minus 2 omega square upon omega square plus 2 omega plus 2 into omega square minus 2 omega plus 2. As we know that b omega is 0 in Fourier cosine integral, so fx equal to 0 to infinity a omega cos omega x. Now we have a omega is 1 upon pi 4 minus 2 omega square upon omega square plus 2 omega plus 2 into omega square minus 2 omega plus 2. We put a omega in this formula. Finally we get e raised to minus x sine or x equal to 1 upon pi integration 0 to infinity 4 minus 2 omega square upon omega square plus 2 omega plus 2 into omega square minus 2 omega plus 2 cos omega x d omega. This is our Fourier cosine integral of function e raised to minus x sine x for x greater than 0. Let us see the second example for sine integral. Here express the fx equal to sine x for 0 to pi and 0 for x greater than pi as a sine integral. Here our function is discontinuous function and Fourier sine integral is fx equal to 0 to infinity b omega sine omega x dx, where b omega is 2 by pi 0 to infinity fx sine omega x dx. Our function is discontinuous, so we are dividing into two parts, 0 to pi and pi to infinity. In the 0 to pi our function's value is sine x and for x greater than pi it is 0. So finally our b omega will be 2 by pi 0 to pi fx sine omega x dx and plus 2 by pi to infinity fx sine omega x dx. Now b omega will be 2 by pi 0 to infinity sine x into sine omega x dx plus 2 by pi to infinity 0 sine omega x. Now second integration is 0, so we get only b omega equal to 1 upon pi 0 to infinity 2 sine omega x sine x dx. Now we apply the minus 2ss formula, that is minus cc. After simplifying we get the b omega equal to 1 upon pi 0 to pi cos omega minus 1x minus cos omega plus 1x dx. After integrating this term we get 1 upon pi sine omega minus 1x upon omega minus 1 minus sine omega plus 1x upon omega plus 1 0 to pi. Now put the upper and lower limit in our integration. We get b omega equal to 1 upon pi sine omega pi upon omega plus 1 minus sine omega pi upon omega minus 1. Here we can take the omega pi equal to 0. In the Fourier series we are taking the sine n pi equal to 0, but here omega take value fractional number, that means omega may be a 1 by 2, then sine we have a sine pi by 2 which is not 0, so we can't take here omega pi equal to 0. So here we can't take sine omega pi equal to 0. Here b omega equal to 2 sine omega pi upon pi into 1 minus omega square. Therefore, our Fourier integral is 0 to infinity sine omega x into sine omega pi upon 1 minus omega square dx omega equal to pi by 2 sine x for 0 less than or equal to x less than or equal to pi. So here we seen the Fourier cosine integral and sine integral for continuous as well as discontinuous function. It is very important to develop the Fourier cosine and sine transform. Thank you very much.